Ever wondered how weather balloons expand as they rise or why a sealed bottle of soda fizzes when opened? Both of these phenomena are explained by Boyle's law and Charles's law, two foundational principles in the study of gases. Welcome to Science Bites. Today we'll explore these two gas laws which describe how gases behave under different conditions of pressure, volume, and temperature. First, let's start with Boyle's law. It states that, at a constant temperature, the pressure of a gas is inversely proportional to its volume. Simply put, if you decrease the volume of a gas, its pressure increases and vice versa. This can be expressed by the formula P1V1 equals sign P2V2. For example, imagine compressing air in a syringe. When you push the plunger, the air takes up less space, and the pressure inside increases. That's Boyle's law in action. Next, we have Charles's law, which explains the relationship between temperature and volume. According to Charles's law, at constant pressure, the volume of a gas is directly proportional to its temperature in Kelvin. This means that as you heat a gas, its volume expands. The formula for Charles's law is V1 T1 equals sign V2 T2. A great example of Charles's law is a hot air balloon. As the air inside the balloon heats up, it expands, causing the balloon to rise. These laws are part of the ideal gas law, which combines Boyle's, Charles's, and other laws to give us a broader understanding of gas behavior. The ideal gas law is expressed as PV equals nRT, where N is the number of moles of gas, and R is the gas constant. So, next time you see a balloon expand or a soda fizz, remember that these gas laws are hard at work. Join us next time on Science Bites as we explore more of the wonders of science in bite-sized videos. Like and subscribe to Science Bites for more bite-sized science that makes the universe easier to understand, one concept at a time.